Okay, here is the 11.3 study guide. All right. So you should have already done the lessons and have an idea of what this is about. So let me help you through these. So the lessons talked about similar right triangles, and that just means they're right triangles that have the same shape. So these triangles have the same shape, but not necessarily the same size. Their three pairs of corresponding angles are congruent, and their sides are, they don't have to be congruent, remember, and that's the whole thing with this, is that they are proportional. And we'll find out what that means exactly right now. Number 2, complete the statements for the two right triangles below. Circle the statement that names the congruent right angles. Okay, so this tells us that angle A equals angle D. Nice. And proportional sides are AB and DE. So what's AB? It's 11.4. And DE is 22.8. That's double. So it's proportional if they're all double. Okay? So let's do angle C. What's angle C equal? Angle C equals angle F. And then we do another set of sides. We do BC corresponds to EF. And we see how EF and BC, that's also double. Okay? And then the last one, what angle haven't we used yet? Angle B equals angle E. And that would give us the only side we have not used, which is AC and DF. 3, prior knowledge. Okay. Triangular similarity postulate, you know. If two triangles have two pairs of congruent angles, then the triangles are similar. Right triangle fact, you know. Any triangles have one pair of congruent angles. They're, and then what would we fill in the blank with that one? They're right angles. So if we have two right triangles, and they have one congruent angle, so this one is equal to this one, then we would know that they are the same shape because all their angles would be the same. Right triangle similarity postulate. If two triangles have one pair of congruent acute angles, then the right triangles are similar. 4, fill in the blanks in the summary below. Similar right triangles theorem. If an altitude is drawn from the vertex of a right angle of a right triangle to its hypotenuse, then the two triangles formed are similar to the given triangle and to each other. Summarized theorem. Okay, so the summarized one will probably make a little more sense, or hopefully it did when you learned it. But if you draw an altitude from the right angle, from the right angle to the hypotenuse of a right triangle, you get 3 similar right triangles. So that situation is a right triangle. And if we draw an altitude from the right angle to the hypotenuse, so it leaves the right angle, and an altitude makes a 90-degree angle with the opposite side. All 3 triangles are congruent. So this little one, this bigger one, and then the whole thing. All 3 of them are the same shape. Okay. 5, use the diagram to complete the similarity statement below, and then follow the steps to find BC. Okay, so we have triangle ABC, which is the big one. And we know all 3 of these are the same shape because we have this altitude that leaves the 90-degree angle and makes a 90-degree with the opposite side. So ABC is the big one, okay? So I need to name my other ones. All right, so let's think of this as like triangle number 1 and 2, and then the big one is 3. Okay, so this is 3. So look at triangle number 1 now. Okay, so here's how you do this. When I look at ABC, the first one actually, what is ABC's right angle? It's B. So when I name this triangle number 1 over here, I know that the right angle letter is going to be in the middle, which is D. So it's either CDB or BDC. Maybe pause the video and take a guess and see if you can figure it out. So I can tell that I would look at their hypotenuse, okay? So what's the hypotenuse of the whole big triangle? That's AC, right? What is the hypotenuse of triangle number 1? That's BC. So in my congruent statement in the beginning, I see that the hypotenuse AC, those two letters are first and last. B, C, and then remember we said the right angle would fall in between. So that's BDC. Now we got to look at number 2. What is number 2's right angle? Well, it is also D. And then we have to decide if it is ADB. And this one is going to be ADB. Okay, right proportion statements using the side names. Make sure the unknown side is in the proportion. Okay, so when I do these can be super confusing, guys. So I just check to make sure that everything looks good, okay? And here's how I check, okay? So what I do is I just, I kind of look at it like, okay, each triangle has a really short leg, right? And let's make sure that all the short legs line up. All right, so looking at the biggest triangle, the whole big thing, I see that this right here is the shortest leg of the whole big triangle, BC, right there. So that means that DC, that better be the short leg, and DB better be a short leg, okay? And keep in mind, this is the big triangle, which we called 3, and then we had, I think this was triangle 1, the little one, and this was 2. So from triangle 1, is it true that DC is the short leg? Yes, it is. And for triangle 2, which was the one on the left, is it true that DB is the short leg? Because it's the last 2 letters, and it is, so we're good. Write a proportion using side names and make sure the unknown side is in the proportion. This does AC over BC, okay? So what it's doing here is AC is right here. AC, remember how that was the hypotenuse of the whole big triangle? And then it seems like it's lining it up with BC, okay? So BC is the hypotenuse of which triangle? It's the hypotenuse of this one out here. So I can tell it's comparing the whole big triangle on this one to the triangle on the right. I'll just call it the triangle on the right for now. Okay, so it lined up the hypotenuse of the big one. Okay, so I could say like big hypotenuse over BC, which is the right triangle, or the triangle on the right, its hypotenuse. So those are the 2 that we're comparing, the big one and then the other one. And then it has like a DC down here. So I have to ask myself, okay, I have the triangle on the right. It's in the denominator, right? So what's DC to that triangle? It's the shortest leg. So now what's the shortest leg of the big triangle? Shortest leg would be BC. You might try these and then come back. plug in numbers and variables. Okay, this is 7 over x. So 7 they get from here, 4 plus 3. So again, that's the hypotenuse of the big one over the hypotenuse of the right triangle is equal to 3, which was the short leg of the right one, over, and then x, let's say 7 over x is equal to 3. Let's see, now they have 3 on the bottom, so it helps to write it out here. So let's write this out. 7, I have my big triangle on the top. And I'm going to call this, let's go back to calling them 1 and 2, because if I call it the triangle on the right, then I'm thinking it's like right triangle, which they all are. So I'm going to call it 2. So I'm going to call it triangle 2 is on the bottom. So if I have 3 as part of triangle 2, it's the small leg of triangle 2. So that means I need the small leg of the big triangle on the top, which is x. Okay, so I would have to now solve this proportion. So I cross multiply, and x times x is x squared, and 7 times 3 is 21. And now I just take the square root of 21, and I figure out that BC is equal to the square root of 21, which is 4.58. How far down, let's see here. Fill in the blanks, miniature golf problem, pages 14 to 19. Okay, I don't actually have that one. So hopefully that first part was helpful for you. I don't have a way to turn to that right here. So I think that is going to be the last one that I do. I might be able to get it for you guys, actually. Let's see. I see the picture here. Let me just draw the picture on here. So the picture that you should draw for this miniature golf problem looks like this. Oh, this is supposed to be dotted too. Okay. So there is the picture that you're supposed to get from the golf problem. Okay. So the hole on this one is supposed to be 15 feet away, and you need to bounce it off the wall. And then 2 says they make 2 right triangles, and we need to prove that they are the same shape or similar. I will use proportions to solve the problem. Okay, so what do we know? Well, we know that these two, I need to prove that these two are actually similar. So, okay, so it gives us a clue here. ABC is equal to DEC because they are both right angles. So we could also give these letters here. So we're going to make this A, B, and then this will be point C. And this one will be D, E, C. Okay, so this one is saying that ABC and DEC, those are both right angles. And ACB is equal to what? ACB is equal to DCE. And if those two are similar because of the AA similarity postulate. So if the two angles are the same, then you know the triangles are the same shape. So use similar triangles to write and solve a proportion. Okay. Now it actually wants you to figure out what x is. So, I wish I had that. Maybe I can cut this and bring it down. No, don't want that. If I go like this, and move it down here. Okay. Doing my best here, guys. I think that's pretty good, though. Let's just stick it right there. Okay. So this is saying AB over BC. Okay. And then is equal to DE over what? Okay. So we have AB over BC. Okay, so it's taking AB, which is this part right here, and we're putting that over BC, which is that part right here, so that equals DE over EC. Okay, and there's a few ways that you could do this one, actually. So AB is 6, and then we know that BC is 15 minus x. So, I'm trying to figure out where that 15 minus x came from. Maybe in their drawing, that's actually 15 minus x and not x plus 15. Let's see here. It is. That's 15 minus x. So this is 15 minus x. Okay, so that's how that gets substituted there. And then we get 3 coming from here over 6. All right, oh no, 3 over x. So again, if you didn't catch that, we had AB over BC is equal to DE over EC. So we're lining it up like that on this one. Okay, now we cross multiply. So we go this times this, that's that. And then this times this is 6x. And then I got to solve this. So I distribute for 45 and negative 3x. And then I add 3x to both sides, and I divide by 9, and I get x is equal to 5. So you need to hit your ball 5 feet down the wall to make a hole in one. Okay. So I really wish that this would have been on there for us to look at. So sorry it took a little bit of time to draw, but hopefully that made sense that we're lining up these different sides to kind of make sense of the problem. Now, I actually would have done it a different way. So let me show you how I would do this problem. So if I was just looking at this without all those weird prompts, I know that I'm dealing with two similar triangles. So I have like triangle 1 and triangle 2. So I would be like, okay, well, I know 3 matches up with 6. And that must equal x, which matches up with 15 minus x. And then I would cross multiply and get the same thing that they did. But it's just kind of written a different way. That's not 34, though. This is 45. And I think that way makes a little more sense when I think about it. So hopefully that helps.